Good morning, everyone. I've been offered to fill in the next 20 minutes as one of the other speakers wasn't able to make it. And so I've put together a presentation which hopefully pulls together a number of strands that have been brought out over the last couple of days, specifically to sort of environmental issues, the concerns associated with shale gas fracking. And that is going to be my presentation. So specifically, I'm going to just do a little bit of background to myself and my company, and then just mention living with petroleum. It's something which certainly in the UK we are not unfamiliar with, and then looking at the public perception, and then specific environmental concerns associated with shale gas, and the role that continuous monitoring can assist in that public addressing that public concern. So, background to my company. It's quite a young company. We set up in 2004, and we provide specialist environmental monitoring services to the contaminated land sector, but also to the onshore petroleum sector. And we have been, we're based here in Manchester, and it's actually great to have a conference here in our hometown for a change. But we've also got presence around the UK. Currently we've got contracts with Quadrilla and iGas, and we are in negotiations with a number of the other key operators within the UK. So, environmental monitoring, just putting it into perspective, there's a sliding scale here between doing nothing and doing too much, and there's an increasing cost along that continuum. And we're very concerned on trying to provide a technology which actually meets that regulatory level. If you don't meet that regulatory compliance point, then you may result in refusals or enforcement action. And it really is important that that regulatory line is well understood and well defined. And as we've heard from other speakers, we've had a lot of goalpost moving on this particular issue by a number of regulators in the past couple of years. And if you go beyond compliance, then you could be potentially wasting your money. However, there's another line which comes into play, and that's the social acceptance line. And as communities get more familiar with shale gas, those two lines should actually get closer together. Potentially, and at the moment it's arguable that those two lines are quite far apart. And another thing is, it's not a question of getting a monitoring regime which is one size fits all. It's important to actually get a regime which is suitable for the particular site specifics, and indeed for the cycle, the part of the exploration or production cycle that the operator is in. So let's look at the public perception around this issue. And this quote from Nick Greeley from No Hot Air, I think, sets out one position which I think a majority of you in the room would probably share to a greater or lesser extent. Shale gas is a game-changing transition fuel, providing security of supply, local employment, reduced energy costs, and reduced greenhouse gas emissions. I think you could put the word potential in there, and then I think most of us would accept that. And the alternative view, this is a quotation taken from a Frack-Off website. Shale gas is an extreme energy that is associated with toxic and radioactive contamination of water supplies, air pollution, earthquakes, and runaway climate change. Luckily, I think we are moving away from this opposite ends of the spectrum, and I think there's a greater consensus of the real risks and real concerns about this industry. But Gasland's been mentioned before. This has caused a lot of problem for the industry, and that is what has people have been working hard to get over, to get by. But it's the fuel for a lot of these pressure groups and activists, and these are a number which have been quoted by other speakers. And in particular, in this neck of the woods, in Quadrilla's licence area, we've got the Ribble Estuary Against Fracking group. And there are pressure groups which do demonstrate not only outside events like this, but also actually on sites. But there are some real concerns which need to be understood by the key players, by the operators and their consultants. And I think these concerns can be split down into three categories. There's the factual questions. What is going to be happening? How is our area going to be affected? When is the drilling going to start? How long is it going to be? Is it going to be 24/7 lorries driving past my house? These are all valid questions which need to be addressed. Then you've got the structural questions. But you're going to be industrialising the countryside. What about the farming and the tourism issues? And then thirdly, you've got the fear and mistrust group. And these are real quotations from real people at a public event. In this case, it was a public event carried out by Tamboran in Northern Ireland. But the question was, if there's a serious pollution incident, it will be the local people who will have to live with it. And why should we trust shale gas operators? They make the money, but leave the small people to clear up the mess. Well, let's have a look at some of the concerns and how those questions can be addressed. I've seen this one before. It's actually taken from the Frack-Off website, and it identifies a lot of the key concerns which have been already discussed. You've got air pollution, you've got flaming faucets, you've got potential contamination of aquifers, and fractures propagating up towards the surface. But it is very stylised and is very misleading in how it portrays those issues. I believe this is a much more accurate way of showing the real issues associated with shale gas. And apologies to Eric, who recently corrected my sketch and put the fractures in a more realistic way. But the main point is that this is a scale section with a pad at the top and a geological sequence down to 3 kilometres where the fracking operations may take place, and the intervening strata in between. So there's a huge thickness of rock between any surface community issues and where the actual industrial process is taking place. But let's go through each of the concerns in turn. And again, I'm reiterating some of the points made by other speakers earlier. Earthquakes, fractures opening up to the surface, well casing bursting, contamination of aquifers, and the surface spill potential. Starting at the bottom, let's look at this fracturing business in a little bit more detail. Well, Eric gave a very good summary of what's actually physically involved in hydraulic fracturing. But the point which I'd like to bring out here is that you actually, the operators drive those fractures to where they want them to be. And by mapping where they are occurring, you can actually get accurate information on the length or the height and depth of those fractures. And This is another slide you've seen before. Those heights of the fractures can be determined and put in perspective in respect of near surface water resources. This is 2 slides taken from fracking activity in Marcellus and the Eagleford, as reported in the Royal Society report. And we've now got this sort of information in 3D, with 3D microseismic mapping, whereby each frac job can be accurately mapped almost as it happens in 3 dimensions. Moving up, what about the well integrity? What about a potential leakage through the casing? Well, under best practice, the well casing will be very well constructed, and the design will be approved and inspected by appropriate independent teams. I think it's the next slide. But there is this perception that there is a potential for a casing failure, which could lead to contamination of the aquifer, or the cement job around it, around the casing, may not be particularly well carried out. And I've got the same problem again. I apologise. Can't move on. And you may get contamination through the flowback waters or formation waters, or indeed the fracking fluid itself coming up the annulus, and again contaminating the near surface aquifer supplies. And then finally you've got the risk potentially of a surface blowout. But I mentioned Gaslands earlier, that Josh Fox film, which portrayed so much misinformation. Well, there's a sequel produced by the American operators called Truthland, and I recommend you have a look at that as a counterpoint to the misinformation. And this is a slide taken from that video showing the different casings which are used to protect a shale gas well. And you can see that actually there's going to be significant thicknesses of steel and cement protecting certainly the near surface aquifers and water supplies. And that construction can be adequately checked by cement bond logs, etc. Blowouts, well, they do occur. And if they do, then it's a major health and safety issue. But all operations will have a blowout preventer used in the exploration and production phase. So let's move right up to the surface and the potential for surface spills. Well, here we can look at developing best practices for containment, and indeed if you've got a well engineered well pad, if you do have a spill of contaminating materials, then they won't go beyond that containment system. However, there's another role, and that is, despite having good regulation, good best practice in operations, there's another role, and that is actually to demonstrate that all of those systems are working adequately, and that's the role of environmental monitoring, sampling and testing. And in line with recommendations from the Royal Society and others, it's important to do this before, during and after operations. And a lot of the misinformation coming out on the risks of shale gas stem from the fact that the industry, which was developed in the States, the operators didn't carry out baseline monitoring before the operations took place. So they didn't have any evidence to hold up to the activists who are complaining about gas in the drinking water. And the gas in drinking water may well have been, and has been written up in a number of papers as already being pre-existing, either biogenic gas from near-surface sources, or naturally migration of thermogenic gas from deeper down over geological time. How we carry out our monitoring is by having independent monitoring wells around the well pads, and these target sensitive receptors in the near-surface drift deposits, and indeed in the near-surface aquifers, with response zones designed to target those receptors. And we continuously monitor those with a variety of devices which sit permanently in those monitoring wells, and thereby we collect continuous data. And the importance of continuous data is shown on this slide here, where I show you what may be recorded by periodic weekly samples, but the weekly samples miss what is a true picture of variability in this case, natural landfill gas or methane concentrations associated with landfill gas, and a migration plume of landfill gas came through this particular site over a very short duration. But you got concentrations of methane up to, I think that says, about 80% within just a few hours, and then back down to close to zero again. So the continuous monitoring which we carry out picks up that natural variability or indeed artificial variability associated with former or existing contamination in and around the well sites. And this is a typical presentation of continuous data for a month at an exploration site, showing not only the ground gases, but also some of the driving mechanisms, the driving parameters, such as atmospheric pressure or temperature. And at the bottom, we've got groundwater levels. This particular site was affected by tidal influence, and we had brackish water flowing in and out of the near-surface aquifer in sequence with the changing tides. This is the tidal change, neap and spring tide variation over a 16-day cycle, and response in the aquifer with, in this case, the water level and electrical conductivity, which is a proxy for salinity. Also, very important to, if you've got methane recorded in your near-surface soils, taking samples to actually fingerprint it with, say, isotope analysis. So in addition to continuous monitoring, we take regular samples for laboratory analysis. Thank you very much, and I hope that's been of interest.
So I have one question. How does the system of continuous monitoring differ between the US and the UK?
Certainly, continuous monitoring of ground gases is something which we developed here in the UK in the last 6 years or so, and the technology only came to market about 4 years ago. In respect of baseline monitoring in the States and environmental monitoring generally, I think the systems we have are in advance of what's been done in the past in the States.
And the other question I had was, we probably all saw the Horizon programme recently, and the bubbling water of the bubbling methane. What can cause that, and what's the likely causes?
Firstly, there's a lot of widespread communities across, say, Pennsylvania. And I haven't actually visited there, but from speaking to people who have lived and worked in that area, each homestead will have its own water supply. It's not connected to, it's like a local grid. So they'll have their own water well next to their house. And that well will be sunk down to a local aquifer below the property. Now that aquifer could be in hydraulic connectivity with naturally occurring gas-containing rocks, or there may be near-surface peat deposits which are giving rise to methane, which get into that water supply.
Okay, thank you. Anyone got any questions from the floor?
Thank you. Steve McManaman, US Bakken Services out of Bismarck, North Dakota. Question, have you noticed any anomalies to date with your continuous monitoring programs?
Anomalies associated with potential well integrity incidents?
Correct.
The answer is quite short, no.
That's what I would expect. Okay. Thank you.
Glenn Williams, EPIV, investors in oil and gas services technologies. What's the attitude of the oil and gas operators that you work with in terms of the commercial relationship? Sometimes when services of this type are procured, they're often procured at the lowest possible price point because they may not necessarily add value. How is the industry accepting the need to do the surveillance and monitoring?
I think that's a question you need to address to the operators. However, from my perspective, we do add value and we do provide a cost-effective service. And for this reason, that with the evidence, continuous evidence that we gather, we can counter any arguments coming from a disaffected local community that something untoward has happened. Without continuous evidence, it's very hard to do that. So in terms of winning hearts and minds, we have a system and an evidence base which actually does add value to the operator's work.
Andy Clifton from RPS. I'd also make the point as well, in terms of adding value, one of the key things with a baseline of site is it's pretty much a regulatory requirement as well, so you're not going to get your planning, you're not going to get your permitting if you don't understand your site. And that's not just the monitoring side of things, it's all the relationships in the environmental setting of the site, how deep your geology is, how deep your shallow how deep your shallow aquifers are and the relationships between it, so you can counter concerns that come up.
Absolutely, good point.
Yeah, Simon Green, Total. Just a comment, you put up a slide showing a blowout preventer and saying, blowouts happen and people get killed. And imagine if you put a slide like that up in front of an uninformed public meeting, that would cause an amazing amount of concern. Do you have any statistics worldwide as to how many shale gas wells have actually blown out and killed people?
No. It is one of those risks. Blowouts do occur. We saw a slide from one of the other presenters yesterday where we saw such an event occurring. It isn't something I would show to a general public audience. It is something which I would put in a technical presentation to a technical audience.
Okay, but I thought people, associate, the shale gas with the hydrocarbon industry in general, and blowouts and unpleasant events like that are the ones that hit the headlines and the ones that stick in people's memories and minds. So I think we would have to be obviously ready to deal with that kind of concern with statistics which show that the shale gas is perhaps not quite so dangerous as conventional.
The point I would make, I guess, is that drilling a petroleum well, whether it's shale gas or conventional, it's an industrial process. All industrial processes have industrial risks associated with it. It's part of a regulatory framework to make sure that they are reduced to the absolute minimum through the ALARP principle, for instance, as low as reasonably practicable.
General technical comment from across the pond, so to speak, is that what we are seeing is that probably most of the problems we're seeing with gas are actually with former conventional wells that are not properly abandoned. So in general, what we found is that some of these things, like from gas land, are actually from old wells that were not properly abandoned to begin with, and not actually the horizontal fracking. So, thank you.
Thank you for that comment, yes.